Hello, Wayland Middle Schools. Mr. Farley here. I'm starting to feel better and getting closer to returning, but I have one final video for you here today on evaluating functions. Okay, so there are really two types of function evaluations that we are going to be doing. The first one is really, really easy, piece of cake. And let me give you a couple of examples so you know how to handle this when you are practicing some of these in the Fun with Functions monster booklet. So here we go. What happens here? The first situation is you are given an input, and your job is to find the output. Remember that input is the x, all right? So I'm looking right over here at the f of x is equal to the absolute value of 2x minus 5 minus 3x plus 2. It's kind of a crazy looking function notation expression right here. I want you to evaluate it for the f of -1. Now remember, -1 here, this is the input. So this means -1 is being inputted into the function, and our job is to find the output, or what that will be. So here we go. This is what it looks like. You are going to input -1 into this equation right here. So wherever you see the variable x, you are going to substitute -1 for x. And you can see that's exactly what happened here in the second line. The input of -1, x turned into -1, and then x again turned into -1 here. Now you just have to evaluate this. That's all you have to do. And if you check the math, I think inside the absolute value, we will have -2 minus 5. Outside the absolute value, we have +3 and a +2. So if I go further evaluating this expression, you can see -2 minus 5 is -7, and 3 plus 2 is 5. Absolute value of -7 is 7, and if I add 5 to 7, I end up with 12. I'm going to move this little toolbar here so you can see there it is. So it evaluates all the way to 12. So that means when the input is -1, the output is 12. So I would read this as the f of -1 equals 12. All right, let's try the second one. We have another expression over here. I want to evaluate it for the f of 4. That means the input is going to be 4, which means wherever there's an x, I am going to substitute 4 for that value. And you can see I did that here in the second line. I plugged in 4 for x, plugged in 4 right here. And now I just have to evaluate it. Order of operations are crucial here. If I square 4, I get 16, and I just evaluated it a little bit further to get 48 minus 4 plus 5. Order of operations tells me to work left to right. 48 minus 8 is 40, plus 5 is 45. So you can see the f of 4 equals 45. What that means is if the input is 4 for this particular function, the output is going to be 45. And that's a basic way of evaluating a function. All right, take the input, whatever it is. In the first example was -1, and then just plug it in. Second example was a 4, then just plug it in. All right, and then you can evaluate any function at all in this manner. Let's try the next one. This one's a little bit harder, but still not that bad. Okay. So this time we're going to find the input when given an output. So this is a little bit different. And you can see the notation here f of x equals 10. So right now, our job is to find the input. I want to know what the input is. All right. But I do know the output is 10. So that means my f of x can be turned, which is the output. Remember, f of x is the output. If the output is 10, just plug it in. Output of 10 is equal to 2x plus 5. And now you kids can do this in your sleep. You can just solve for x, and that will be the value of the input. So subtracting 5 to both sides, dividing by 2, I hope we get x is equal to 5 over 2, or 2.5. So that would be the value of x. We found the input once we knew what the output was going to be. Looking at the second one, f of x equals 12. This is saying the output is 12. So our job is to find, well, what value of x will give us an output of 12? Well, f of x turns into 12, and I have this equation. We remember how to do this. You want to isolate the square first, so let's add 4 to both sides. That gives me 16 is equal to x plus 1 squared. And now I hope bells, whistles, sirens, and strobe lights are going off in your head right now, because in order to get rid of a square, you need to square root both sides, which leads us to the absolute value. Keep that in mind. I'm not going to work this one out for you, but I think you get the picture. Output is 12, make the output 12, and then solve the equation for the value of x. In this third example, it's an absolute value. The output is 15, so make the output 15. Put it right in there, and now you solve this absolute value equation. So remember, for these, we are trying to figure out what the inputs are, but the good news is we are giving you the outputs to help you do that. All right. And one last one to look at, and this is evaluating functions on a graph. All right. So just like the last one, there are two types that we can do. One, when an input is given to us, and the second one, when the output is given to us. So let's check it out. This first one, the notation says f of 2. This means the input is 2. So what you need to do is, the input is the value of the x. So I'm going to look at this graph. I'm looking at x value of 2. That's the x-axis of 2. I'm going to follow it all the way up and see what the output is. It looks like the point 4 right here. The value of y is 4. So the output will be 4 when the input is 2. So that's what we're looking for. F of 2 would then equal 4. That's what this graph is telling us. Let's try this one. F of 8. That means the input is 8. Our job is to find the output. So I go to the graph, input 8, check on the graph, and look, it appears right here that the output is 2. The value of y is 2 when the input x is 8. All right, so f of 8 would equal 2. Let's go the other way. Now we're saying find the f of x, okay? Find the input x if the output is 1. That's what this notation is telling us. So I'm going to look on the graph, output of 1. So here's 1 on the y. The only place where there's an output of 1 is right here, and that occurs when x equals -1. So I found x to be -1. It's the only spot where the output is 1. Let's try this one. Where is the output 6? I look here on the graph. I see this looks like an output of 6. Here's another output of 6. And here's a third output of 6. So in this case here, we have value of x can be 4. So when x is 4, there's an output of 6. When x is 6, there's an output of 6. And when x is 9, there's an output of 6. So in this case, there are 3 different times on this graph when the output is 6, and that occurs when x is 4, when x is 6, and when x is 9. Last but not least, when is the output 4? That's what this is trying to tell us. So I look at the graph. This looks like an output of 4 right here. That's when x is 2. Over here, it happens again when x is 7. And it happens again right here when x is 8.5. All right, so there are, again, 3 different times on this graph when the output is 4. And that exists when x is 2, when x was 7, and when x is 8.5. So hopefully that helps you out a little bit with evaluating functions. We can do it from a graph, and we can do it when given an equation that or an expression that needs to be evaluated. Hopefully we learned something new. Check out this video one more time. If you had any other questions, reach out as always with emails. Looking forward to seeing everyone soon. Take care.